Okay, we're going to be doing the integral of e to the x of 1 plus e to the 2x dx from negative infinity to infinity. Right away, you can tell this is an improper integral because of infinity, negative infinity. These aren't finite numbers. So the very first thing you want to do is split the integral. Now you could split the integral anywhere you want. I'm going to be choosing 0. It's just easier to plug in. So from negative infinity to 0, e to the x, 1 plus e to the 2x dx, plus the integral from 0 to infinity of e to the x, 1 plus e to the 2x dx. Now, this lower bound and this upper bound are still problems, so we're going to want to fix that by setting limits, approaching this and this. So the limit is, I'm going to be using the variable a, approaches negative infinity of the integral a to 0 of e to the x, 1 plus e to the 2x dx, plus this is the problem here, so the limit, as I'm going to be using the variable b, approaches infinity, the integral from 0 to b of e to the x, 1 plus e to the 2x dx. Now I'm going to be solving the integral on a different page. I like doing this because you're going to be doing the same integral twice. So if I solve it as if there was no upper and lower bounds, I could just plug it in and then apply those bounds. So the integral of e to the x, 1 plus e to the 2x dx. Okay. Now, what I like, the very first thing I do is I try a u sub. I see that there's an e to the x here, there's an e to the x down here, so I'm going to set u equal to that. U equals e to the x, du equals e to the x dx. It works because e to the x dx is here, so e to the x dx becomes your du, and the e to the x here is going to become u. So in the denominator we have 1 plus e to the 2x, which equals 1 plus e to the x squared. So then this e to the x is going to become your u. So the integral becomes 1 over 1 plus u squared, and then your du. Notice that this is tan inverse. It's going to become tan inverse of u, and there's a plus c. Plugging your u back in, you're going to have tan inverse of e to the x. There is a plus c, but since I'm plugging this here into a and 0 and b, you don't need the plus c. So we're going to have the limit as a approaches negative infinity. We just evaluated what this is, which is this. So tan inverse of e to the x from a to 0 plus the limit as b approaches infinity. same exact thing, same integral. Tan inverse of e to the x, except the bounds are different, 0 to b. Now, plugging in your upper bound, we're going to have tan inverse of e to the 0 minus tan inverse of e to the a. This is an a. Bring your limit back down. It hasn't been evaluated yet, so you keep bringing it down until it gets evaluated. Bring this limit down. B approaches infinity. I'm going to plug in this bound and this bound. Tan inverse of e to the b minus tan inverse of e to the 0. E to the 0. Okay. E to the 0 equals 1. So we're going to get tan inverse of 1 minus tan inverse of e to the, that's an a. But a approaches negative infinity, so we're going to have tan inverse of e to the negative infinity plus tan inverse e to the b. B approaches infinity, so we're going to have e to the infinity minus tan inverse of e to the 0, which is just 1. Okay. Now, what we're left with is tan inverse of 1. Tan inverse of 1 is pi over 4 minus tan inverse of e to the negative infinity. So it helps to look at a graph of e. E looks like this. E approaches negative infinity. As e approaches negative infinity, it's going to 0. So this is going to become tan inverse of 0. And the tan inverse of 0 is 0. So we're going to get tan pi over 4 minus 0 here, plus tan inverse of e to the infinity. Well, if you look at the graph again, e to the infinity is infinity. So tan inverse of infinity minus tan inverse of 1 was the same thing as over here, which is pi over 4. All I have to do is figure out what tan inverse of tan inverse of infinity. Well, we set tan inverse of infinity equal to a variable, doesn't matter which one. Tangent of y equals infinity. Tangent of y equals infinity at pi over 2. If you look at it graphically on a graph, do the asymptote at pi over 2. It's going to look something like this. So it's going to approach it at pi over 2. So y equals pi over 2 minus pi over 4. So we have this plus this. I'm going to rewrite that here. Pi over 4 minus 0 plus pi over 2 minus pi over 4. Now this pi over 4 cancels with this pi over 4. This is just 0, so we're left with pi over 2.